Hi guys, welcome. Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a different category of matrices that is known as a diagonal matrix. Diagonal matrix. Now that we have talked in our previous videos about the concept of a null vector or a single column or row vector matrix that we defined as a vector. Today we are going to look at a different category of matrices that are known as diagonal matrix. Now, suppose we have this kind of example for matrix that is A, B, C, D, E, F, G, H, I. So suppose it's the different elements that are making up of that arbitrary matrix that I've given using the alphabetical letters. Then from the definition of different parts of regular figures or in geometry that we talk, we have the concept of a diagonal line. Now in this case we can have that characters A, E, I, or elements A, E, I lying along that diagonal from the top left to the bottom right. Similarly, we can have this, that is C, E, G, that are lying from the top right to the bottom left. But we are going today to look at a kind of an arrangement that has got elements appearing as this. So this A, B, C, D, E, F, G, H, I. And then we're going to look at this diagonal, this one, that is running from the top left to the bottom right. Now this diagonal has got a specific or a special name that is referred to as the main diagonal, the leading diagonal, or the principal diagonal. So basically this can be the main, the leading, or the diagonal, the principal diagonal. So whenever I mention the term the main, leading, or principal diagonal, it basically refers to the diagonal or the elements of the diagonal that runs from the top left to the bottom right. So therefore this is going to give us a definition of this type of matrices that are known as a diagonal matrix. And we're going to see that these are matrices whose every character is 0 except in the main diagonal or the principal diagonal as I've defined it. The main diagonal that is running, for instance, from the left, the upper left to the lower right, that I've demonstrated, of course, is the one that we are going to use as our main or leading or principal diagonal. So therefore, from the definition, that the diagonal matrix, which is a matrix whose every entry is 0 except the main diagonal, therefore for us to represent this one as a diagonal matrix, we're going to substitute these other elements as 0 and leave the main or the principal diagonal as that. So this kind of a matrix that has got entries, all other entries 0 except the main or the leading or the principal diagonal, is what we call a diagonal matrix. So in this case, for a diagonal matrix example, we can give just a general representation for the diagonal matrix. Now suppose a matrix is given by that alphabetical letter C. Now that we have been using A, then we can give it a general representation as C, first column, first row, and then C, second column, second row, second row. Therefore, for a square, now that we have defined a square matrix in one of our videos, then we can say that this is all these other characters are 0 except the main, the principal, or the leading diagonal. So that one basically defines what we call a diagonal matrix. I can give an example now that we have been using general terms to represent that. So suppose I have a matrix of this nature. I have matrix D, which is 1, 0, 0, 0, 3, 0, 0, 0, negative 2. So this is an example for a general, not a general, specific. This is an example of a specific diagonal matrix. Now that the characters, the leading diagonal, have those figures and the rest of the elements are 0, so that is what we call a diagonal matrix. Now there's a special category of diagonal matrices that have got this leading or the principal diagonal containing characters of 1. So suppose I substitute those by 1, then the name of that special category of diagonal matrix is known as an identity matrix. So this refers to an identity matrix. And from our basic mathematics, identity actually implies or represents one unit. So in that case, we can have an identity matrix represented as that. So for an identity matrix that has got or of order n, that one now can be represented. So an identity matrix of order n can be represented, of course, as that. This is n. So an identity matrix of order n can be represented as that. So in case we come across this special category or just the concept of a diagonal matrix, of course, if we are mentioned, it is mentioned in a problem that a diagonal matrix has characters this and that, then we know that the concept of a diagonal matrix is a matrix that has got characters only on the principal diagonal and can be of order n, and whenever this diagonal has got characters of 1, then therefore that one represents an identity matrix. Suppose a last example, suppose a matrix A has got or contains those kind of characters. Say this one implies an identity matrix. So that is it for today, guys. I hope that we have understood the concept and we are going to apply it or refer to the video in case of need. So that is it. Bye. God bless you.